Okay, in this problem, we are working on function transformations, specifically shifts of functions. So we're going to be trying to figure out how the shifts, or the translations, as they're called sometimes, um, of this function work out. So they give us coding along with a graph here to figure out how this graph changes. Now, what you want to do is look at the parent function and pick some anchor points. The most important one to track is this red dot I'm going to place at what's kind of like a vertex. It's certainly the maximum point there, and on either side of that point you see pretty predictable behavior. So if I go left 2, down 2, I end on a nice little anchor point there, an easy to find spot, and I'm going to pick another anchor point to track on the right wing of that absolute value function as well. Now, what we're going to do is look at the question here. It says, which of the following is the graph of y equals f of x plus 3 minus 5? Whenever you see addition or subtraction on the inside layer, whether it's just f of x notation like this, or on the inside layer of a explicitly defined function, you're going to be shifting horizontally. In this case, the addition of 3 is going to be a shift left 3. Okay? And then on the outside layer, addition or subtraction of a constant is a vertical shift. In this case, minus 5 is a shift down 5. So we're going to take these red dots, and I'm going to start with the main one on f of x here, and I'm just going to sketch out in blue and green where that dot's going to go. The other thing you'll notice is the scale is going by 2's. So you've got a 2, 4, 6, 8 going on here, but also on the y-axis as well. So be careful there. Sometimes the counting can be a little confusing when you forget the scale. So technically this point that I'm starting with is at 4, 8. So if I shift it left 3 and down 5, it's going to end up, left 3 is going to put me at 1, and then down 5, from a height of 8 down 5 will be at 3. So we're going to end up with that red dot moving to a spot right there at 1, 3. So I'll label that 1, 3. Okay. Now, if you're good with the straight line tool, you can kind of just eyeball that and see where that goes from there. It's a little bit different because the other one was kind of shooting through the actual grid lines on this scale. I don't like the way that one placed, so I'm going to undo, try to draw that again. Actually, you know what? I'm going to snag that other, and I'll use pink for this secondary anchor point. Remember we went left 2, down 2 to get to that one? Well, I could do the same thing from my new anchor point. I could go left 2, down 2. Or I should say I went, I'm keep misspeaking because of the scale here. This is really left 4, down 4. Or what might be better, even though that's an easy pattern to find, is to say, hey, this original point is at 0, 4. So if I go, like I said before, left 3 and down 5 from 0, 4, I'm going to be at negative 3, negative 1. So that's negative 3, negative 1 puts me right there. Okay. And now placing that that new line should be a little easier. Kind of still hops a little bit. I think you get the idea. Then this other anchor point over here started out at 8, 4. So moving left 3 and down 5, I'll end up at 5, negative 1. So right over here. And that didn't snap. Let me try that again. My line tool is a little picky. Okay, so we should get that, and I'll highlight it here, this red curve for our answer. Since we're dealing with multiple choice, this is clearly answer B, now that we can go kind of pick the one we want. And you could find those same anchor points that we just used as we went through this right here on the graph, if you count them out. So don't forget, if you're on the inside layer, you're going to be moving left or right, depending on if it's addition or subtraction. Adding takes you to the left, subtracting takes you to the right. That's on the inside. And then on the outside, adding takes you up, subtracting takes you down. All right, I hope that helps.